Like the Egyptian numerals that we talked about in the last lecture, the Roman numeral is an additive system. It isn't a positional one in the modern sense, but as you'll see, position is starting to become significant. Right? The big improvement that we're going to see here is some modifications that impact some of the inefficiencies, having used a lot of characters to write large numbers that we saw back with the Egyptian system. So you can see in the digits here one of the advantages that the Roman system brings to the table. By breaking with the strict powers of 10 and adding intermediate numbers, if you will, at 5, 50, and 500, writing numbers with digits greater than 5 is going to require fewer characters. Okay, so let's look at some examples. Writing numbers using Roman digits is still very similar to what we saw with the Egyptians. For example, if we wanted to write 123, we would start with a C for 100, then two X's for 20, and then three I's. I know they kind of look like a 1, right? It's just the font. Those are actually the letter I to represent the 3. Something like 523, for example, again, takes advantage of those additional digits by only requiring 1D to represent the 500 rather than 5C. So you're kind of seeing some of that efficiency there. I said in the introduction that position can be significant with Roman numerals. And that takes us to the second efficiency improving rule. As we saw on the last slide, when the digits are in decreasing order of size, for example, hundreds, then tens, then ones, you add them to get the result. When you have a smaller number in front of a larger one, on the other hand, you subtract their values. For example, if we wanted to write 9, instead of doing V and 4 I's, I would write just IX. Right? Since the first digit here is smaller than the one after it, the value would be 10 minus 1, which gives me the 9 I was looking for. All right, so let's look at one more example just to kind of see the power of this. If we wanted to do 999 using just the addition rule, we would need a D and 4 C's, followed by an L and 4 X's, followed by a V and 4 I's, for a total of 15 characters. Using the subtraction rule, the result would be just CM, XC, IX, down to 9 characters, right? CM is 1,000 minus 100, or 900. XC is 100 minus 10, or 90. And IX, as we already saw, is 9. Now, some of you may be looking at this and thinking, why didn't he just do IM? Right? That'd be 1,000 minus 1. There are some restrictions on the rule that limit what digits can go in front of others. I've got them summarized here. The general rule, you kind of look these over and look for the pattern, is that a digit can only be placed before the two digits that come immediately after it in order of size. So an I, that's a 1, right? A 1 can only precede a 5 or a 10. A 10 could only precede a 50 or a 100, and so forth, right? So we couldn't put a 1 in front of an M, and M is way too far up the order. Now, for very large numbers, there's another rule that helps to shorten the number of digits required. For numbers greater than 5,000, at which point writing out the individual digits would start to get cumbersome again, putting a bar over a number meant that it should be multiplied by 1,000. For example, to write 7,000, instead of writing 7 M's, we could write VI, which would be a 7, with bar over it. Now, this is an area where, the rules do start to get a little vague. We could also write this as V with a bar over it, that's 5 times 1,000, or 5,000, plus 2 M's, right? That would be 5,000 plus 2,000, which would also bring us up to 7,000, right? So sometimes here with these larger numbers, there may be more than one way to translate a given decimal number into its Roman equivalent. Now, conceptually, one of the biggest challenges we've had with the systems that we've seen so far is the need to write multiple versions of a digit to represent more than one of a unit. For example, 3 C's to represent 300. Now, one way around this is something called a multiplicative system. Right, so in the next lecture, we'll see how the Chinese implemented this particular approach about 1,000 years before the Romans.